Hey y'all, so I just wanted to get on here to show you guys a quick little preview of a project that I've been working on the past few months, and I cannot even begin to describe how many ups and downs that I've had and how many issues and obstacles that I had to get over that I didn't even imagine that I would have when I first started the project. But I have recently pushed this to my GitHub, so it is in the final stable stages, and I hope that you guys find it as entertaining as I did while creating it. So the title of this video was not lying. I have indeed created my own programming language, and it is not a compiled language, rather it is a runtime language, more of a run and done type of thing. Errors will be thrown out during runtime, objects, variables, all of that good stuff will be created during runtime, and there is no checks that are done before the program is run. So I decided to call this language MSN Code, or MSNC for short, for obvious reasons. It is code written by me, and without further ado, I'd like to show you guys how I built the language and write a few programs in it for you. Alright, so if I come over here to my Eclipse Project Explorer and I go find the MSN project, which is the master folder for my GitHub repository, you guys can feel free to fork that. I'll leave a link down in the description. But once opening that, you can find the folder MSN and MSNC, which is where the main files of my language are kept. And I'm going to open up MSN Code Driver, which I do already have open. And in MSNC utils, you will be able to find CodeLine, which is the main backend of the language, and I'll explain that here in a second. For every program written in MSN Code, all of the lines will be separated into what's called a code line. And each of these code lines separates all of the individual strings, all of the characters of that individual line, which is ended by a semicolon, and will organize all of the line's elements into what that line may be useful for in the future. Meaning that, say a variable may be assigned. This code line will divide this up into what's called the pre-operator, the operator, and the post-operator, in which all three of these things will be used in deciding what will happen with that line when the code is executed. What's better than explaining is probably an example, so I'm going to go ahead and launch MSN Code Driver for you guys and write a couple lines so you can get a better understanding of what a code line really is. So I have here my main front-end UI of my programming language, and you may be able to notice a few obvious elements here, being the editor, which is for, of course, writing the code, methodology, which I'll explain a little later, variables, and the console. The best way to explain to you guys really what a code line is probably by writing a line in my language, so I'm going to start by doing most likely the easiest line you could probably write in my language, and that is going to be an integer declaration and instantiation at the same time. So declaration in my language of a variable, meaning for those who know how to code, this will be impossible. Simply just writing a line like this and declaring a variable, declaring that one exists without a value for that variable. So the proper way to instantiate an integer in my language is by using the indicator I, meaning integer of course, and a space, and then the variable name, which I'll just make int for right now, and I will set that equal to the number 3. And each line in my language does have to end with a semicolon. And with that, I will be able to run this program by coming down here and clicking on the run button. And two things happen with this. So the variable name over here does turn yellow. As I said before, this is not a compiled language, but more of a runtime language. So as the program is running and observing line by line, the program recognizes int as a variable now and will use it as a variable name throughout the rest of the program. And over here in the variables panel, we do have variable int, which is Java's version of an integer, and it is set to the value 3. Also, as I said earlier, this is a string-based language, meaning that a lot of things can't be done in this language as things that are done in real languages. Such as, let me give you an example, let's instantiate another variable here by creating integer equal to 3. So in any other language, this would be perfectly valid, as long as this, would be that language's version of a declaration of an integer. But having no spaces right here is actually an issue for this language because I created this in a manner in which this was divided up into pre-op, op, and post-op. And it does this by splitting up the line by spaces and analyzing this individual line, identifying what exactly the writer was trying to do with this line, and interpreting it in that manner. And when I go ahead and run this program, it will actually give me a nice little error right here that says there was an error instantiating this variable, and that of course when I go back and look at it, it does need to have spaces there. And in running it again, the error goes away, and you can see that another variable was created up here, and integer is now understood to be an integer variable name. Of course, it doesn't actually matter how many spaces there might be. It could always be, you know, something like this, and that is perfectly fine, that is okay, as long as there exists space in between the pre-operator, operator, and post-operator. So I've gotten myself into an issue where there's a little too much entropy in my code and can't really read it. It doesn't really make sense. Of course it does run properly, giving me a little error that says I might be missing a semicolon just because lines are on the same line as other code lines. I can actually come down here to the format button, I can press that, and it will go ahead and format the code, make it a little bit more readable for me, and everything looks all fine and dandy. So I'm sure you guys are dying to know how you print something to the console. Of course, being a new programmer in a language, you might want to be able to print some variable or a string out to the console to find out where you might be having errors. So I have actually two nice little built-in commands, being print and println. And they will print anything to this console that I've created that is before the semicolon. So I can say print hello, hello again, and they will print just like that. And because it is not a print new line, everything will be on the same line, so saying println will put them on a different line. The print function is actually able to print just about anything. So can also print variable names. So I can say, hello, my name is Mason, and I am int years old. And it will go ahead and replace the int with 3 down here. Of course, I'm not 3 years old. As much as I wish I was 3 years old again, I can go here and, oh, wrong button. I can run it, and I am now 21 years old. You guys may be wondering how you might go about printing the variable name itself instead of its value. So I have added a quick little string manipulation kind of thing where you are able to type the @ symbol before a variable name, and you're able to get the name of it. So again, int is 21. So now that we've gone over the instantiation of variables, I'd like to go a little bit more in depth on how these can change throughout the program. So again, we have integer right here, and you can actually easily reassign integer just by saying integer equals 3. You can also say integer plus equals 3. You can also say minus equals. Actually, just show it. Just minus equals 3. So if we go ahead and run this, of course, variable integer will be 3 again. We can even print it down here to make it a little bit more obvious. Integer is integer. Integer is 3, adding 3 to it, subtracting 3 from it. So we can also do integer times equals 3. Integer is 9. And of course there is divide equals 3. And integer is 3 again. And the division in this language is also integer division as it is in Java, so that means if I were to say, let's make another integer. Integer 2 equals 10. Let's say I wanted to divide it by 3. So divide equals 3. And we can come over here and println at integer 2 equals, is integer 2. So integer 2 will be 3. It will not convert itself to a float or double, whatever you may call it. It will just go ahead and do integer division. So here I want to take the opportunity to show you guys something that is a little more beneficial in my language than other languages. So I can go ahead and make an integer right now, being 3. And I also support an operator that I haven't really given a name yet. I guess be exponentiation of a variable. So I can do integer to the power of, and I can say to print integer, and it will be 9, as it does 3 to the 3, and then, 2 to the 3 does 27, 3 times 3 times 3. So I found that to be a little neat, and I also want to show off another operator. So I can make another integer 2 equals 5. Let's get rid of this. So as you can see in the beginning of the program, integer is 3 and integer 2 is 5. So what you can do is actually use the switch operator, integer 2, and it will just swap the two values. Print, let's use ln. Print ln integer 2. So as integer was 3 in the beginning, integer is now 5, and integer 2 was 5, it is now 3. You might have seen earlier that after using the exponentiation operator, as I guess I'm going to call it now, integer actually is converted to a double, so it will show 9.0 down here, and integer up here will be now known as a double. And this can be pretty easily reverted if you don't really care if it's a double. You can actually just go ahead and create another integer. You can say integer 2 equals integer. So as integer is a double right here, and I'm setting it equal to another integer being integer 2, it will go ahead and convert that back to an integer. And that is kind of my language's version of casting. There are no real issues with assigning any variables to any other variables, as it does its best to cast it to the respective type. Now that you guys understand a little bit about the basics of writing lines in my code, I wanted to take this opportunity to show you exactly how you can write in all of the data types. So we have, of course, the integer, and we have a double denoted by D. Double equals whatever you want it to be. And there's also a char. C char equals M. And if this is a string at the end, it will just take the first character of that string being E. So I'll just make it M. And we do have S for string equals hello, this is a stir. Right. And I can come down here and go ahead and print all of these, integer, double, char, and stir. And we'll go ahead and convert those to their respective types and show it all down here. There are also a few special operators for a few special different cases. And these can be the concatenation operator for a string, which is plus plus. So I can come over here and say string plus plus appendation. And then I can print ln stir. And it will go ahead and add it to the end over here. If you are a coder, you may recognize that a very important aspect of a language is speed. So I have these two little keywords built in called time start and time stop. And these will actually log the time between these two keywords and will print it to the console. So I have this little tiny program going on that I wrote earlier, and I can just press run, and it will tell me exactly how many nanoseconds and milliseconds it took to run this. So 0, thank God. We love that. We love seeing 0 milliseconds. But it is fairly quick, being built on top of another language, of course, for its lightweight appearance. So I will go ahead and keep trying to maintain this quick speed throughout this video. I'll try and write the most optimized programs that I can, and hopefully that this number doesn't go much higher than 10. So you may be asking, how do we have this string and append something else to it? But how can we put a space before string and appendation? So I've built in a special little case for this that allows for a space to be added to a string, and that is just ++:w:, and that will go ahead and add a white space right there. Usage of variables within other variables is very flexible when it comes to strings in particular. So as you saw that I printed at integer is integer here, prints integer is 45. We can also, as I wrote the same thing for the string, println stir, it will print the same thing. So I'm going to take this time now to go ahead and show you guys how comments are written in my language. And those are done by writing a preceding double colon and saying this is a comment, or whatever that comment may be. And comments also do have to end in a semicolon, a little inconvenient, but it is what it is. And now I have a nice little comment here. So I can say instantiate integer. Right? I integer equals 3. Of course, I can't just have basic data types. My language does also have its own list implementation, and it is a lot different from the regular data types, so I will go ahead and explain those now. So you can go ahead and declare your own list. Yes, declare. A list is the only variable that can be declared, as well as an object, but I'll show you those a little later. But I will go ahead and call this lst for a list. So I can actually print this list as well. And as you can see, it's just its own little bracket. And its Java type is actually my own original data structure that I've written. That doesn't really matter, but it is still a list type. So to add to a list, you will use the keyword add. So you could say lst add, and really whatever is after the add and before the semicolon will be added to the list in string format. And this is really useful because this means that all elements that are added to a list will be in a string format. So you can actually add every single type to a list, but when those elements are pulled back out, they are then recast to the type that they existed when they were put into the list. So to better explain that, I can go ahead and say list add 3, then lst add, I can add integer to it as well. Add, let's add double, and let's also add stir. So the syntax for getting an element in a list is a little bit more complicated. So I'm going to go ahead and show it really briefly here. It doesn't necessarily matter for reasons that I will explain in the future, but you can actually obtain an element in the list by first creating a variable that you know exists inside of the list. So I know that an integer does exist in the list. So I can say integer equals, I don't know, I could start it with -1. So the syntax is going to be lst get at, and then the index of whatever you want to get. So I do know that this is an integer, and I mean, of course, it says it's a double, but in assigning, things are cast to their respective values. So I can say get at 0, and then I use a lambda integer. So in doing this, it is going to be grabbing the 0th element of this list and is going to be injecting it into integer. So when I do go ahead and run this, it is still going to be 3. However, you can go ahead and say I integer equals integer, and integer will be 3 again. Lists do have their library of commands as opposed to add. They also have contains, remove, remove at, get at, length, copy, join, reverse, unique, which gets, or actually just returns the same list without any duplicates, sort, hash, shuffled, remove white space, which will remove all of the white spaces that exist in a list. And also the last one is going to be clear. It just removes all of the elements in a list. So just a quick example, I'm going to show unique right now, which is removing the duplicates from a list. If I were to type lst unique, that is going to go ahead and remove the duplicate elements. In this case, it was 3. Before I get to anything too complicated, I do want to go over functions real quick, which is basically just a sequence of code lines that can be repeated or reused over and over again. A function can be defined by using f and then the function name. So I can just call it, I don't know, func. And then each function does require closure, so you will say end func at the end. And anything related to functions will be highlighted in red. So for this function, to actually write in the center of the function, you do have to say function equals. So this will be now the first line that will be run by this function. So now this isn't necessarily a post-op anymore. Right now we're back at pre-op. So I can say for this function, we can do integer plus equals 1. So whenever this function is called, it will increase the integer by 1. So I can come down here and say func. This is how you call a function, by just stating it like this, as long as it doesn't have any parameters. And I can print ln integer, and integer will be 4 in this case. And finally, we get up here to methodology. You can see that there exists a function called func with no comments, and it has no parameters and outputs nothing. So it just increases integer by 1, and if I want to, I can call it twice. Of course, it will go to 5, func 6, and that will then bring me into talking about loops. We're still at the 0 millisecond mark as far as time, which is very nice, like that. But when it comes to loops, things are going to get a little bit more resource heavy. So say I did want to call this function just, let's say, 5 times, but who wants to write out func 5 times, right? So any code line can have a special syntax at the end of it that can specify that it is a loop. So I can say func and then 2 brackets, and it will be any 2 integers. So I can say 0:5, meaning that whatever is before this special syntax right here, note that there cannot be any spaces within the entire bracket. They all have to be very compact right there. This will run func 5 times. So if I go ahead and run, you can notice that integer was 3, and now it is 8. I think it's also important to note that these numbers don't have to be literals. They can always be, let's say I start index equals 0 and I start index equals 5. We can use these right here as well, as long as there are no, oh, why did I write that twice? Stop index. As long as there are no spaces, so I can go ahead and do that again. Again, it is 8 from 3. While functions are very important in a language, what is almost more important are conditionals. So conditional runs of a line. So I have built in a special syntax that is 2 curly braces, and again, no spaces between anything. This is a very compact syntax. Whatever is inside of these braces, being a 1 or a 0, will determine whether the line is run. So I can either say 0 or 1, or I can also say I true equals 1, and I can say I false is 0. And I can say true that we will print here. Say print ln. Print here. So it will print because this is true. And if it is false, then it will not run. Again, there cannot be any spaces right here. This is a string-based language, so it is created by splitting at white spaces. Yep, get a little error there, which is nice, but that is how you do booleans in my language. I also have my own little syntax in the boolean brackets for comparisons. So if I have 2 ints here, 1 and 2, we can do if int equals int2, then print here. Of course, they are not equal, so that will not happen. We can also say not equal. We can also say if int is greater than int2. We can say if it's less than. We can say if it's less than or equal to. And we can say if it's greater than or equal to. So now that we've learned a little bit more about conditionals in my language, I'm going to go back and touch a little bit more on functions and how they can vary as far as parameters. So parameters in my language are pretty simple when it comes to convention. So the integer parameters will be called I_param and then 1, 2, 3, or 4, depending on which one it is. And this kind of goes for all types. So, double will be D_param, 1, 2, 3, 4. And so on, including even lists, L_param1, L_param2. It's basically whatever the indicator was for a type, being I, D, C, S. Those will be what the parameters should be for that function. So I'm going to go ahead and write a little function that does have parameters for you guys, and that is going to be an add function. So I can say f_add, let's not call it exactly add, let's say add func. And we can write this, and to actually specify these parameters, we do have to create a string called s, and then this can be called whatever you want. I usually start by saying add func params, but as long as it has underscore params in it, and it is included down here as a part of the function declaration, it will be used as parameters. So you can set these equal to, and then this is another reason why I did use the at symbol. So you can say at I param1, at I param2, and that will be all. And actually you can also specify this lambda if you want to. You don't have to. I just like to make it look nice. And it goes to I return. Again, with variable names, the return value will be the same with the indicator being whatever. It may be D return, S return, L return. But in this case, we are returning an integer, so it is going to be I. So as long as we take the string and put it down here with the function definition, it will use it as parameters. And also worth noting, to make a comment for a function, you also make another string called whatever you want to call it. As long as it has underscore def in it, it will be the definition for that function. Adds to numbers. So now we have that. So we can say add func def, and we can also just throw it in here with the function declaration. It doesn't matter the order of these two, as long as there is a function name and a function indicator right here. So we can also end this function down here, and we can go ahead and write the function. My program basically will be analyzing whatever is in this string. This lambda does not have to be here as long as it recognizes that one of these convention names exists within this string. So it sees this and says, oh, there's an integer parameter, oh, there's another integer parameter, excuse me, and there is a return of an integer. So it knows that, and it will note that in the background for whenever it is running the function. So now we can go ahead and start by saying add func equals, of course, if these variables don't actually exist, we probably should make them in the beginning. Good thing we don't actually have to make these two right now. We do have to make sure that iReturn exists so that it can be given back to the user. So we can say iReturn equals the default value, which I'll make -1 for now. And we could say add func equals iReturn equals I param1 plus I param2. And that's really all you have to do. There is no return value for this. Because all of these values are going to be global, the user will be able to just grab the iReturn and use it from there. As good coders, we are going to go ahead and condense this into one line because otherwise it's probably a little sloppy. But now that we are officially using these two parameters right here, we are going to want to define them up here. So we can say I param1 equals whatever. Doesn't matter the value because it is going to be overwritten in the future. I param2 equals -1. So now we are saying that those exist and those will be used in here, specified right there. So how are we actually going to do stuff with this function? So we can say add func with, meaning that there are parameters for this function, and because there are exactly two integers that will become parameters for this function, we will specify those out here. So they can be either literals or they can be variables, doesn't matter, but for this situation we will use literals, add func with 1 and 2. So now iReturn will be whatever the result of the function is. So we could say println, we could say 1 plus 2 equals iReturn. And now we will get that down here, that 1 plus 2 equals 3, and everything is highlighted, everything looks super nice up here. Functions have been specified, we know what variables are, and it indeed does give us the correct output, being 3. So now this function is actually reusable and can be used with anything else. So down here we can say add func with 2, 3. We could say println 2 plus 3 equals iReturn again, and it will be 5. So all of this is completely reusable and very helpful when it comes to a little bit more complicated logic and stuff like that. So I will go ahead and explain a little more in depth on how these functions can be nested and can be used within each other. Now that you know a little bit more about how functions work and how parameters work, and that functions can vary when it comes to different parameters that you can actually pass in directly from the code editor, you can actually come up here and you can import one of my various libraries that I've written in my language, and you can use the functions that I have already written for you. For example, we can start with string, and any import that is valid will be highlighted in light blue. And after running this and importing it, you can see that it interpreted 111 lines of pre-written code. It has created all of these methods that I've already written for you, getting super helpful things such as sGetAt, gets a character, something, gets a length of a string, an index, a lot of super difficult logic that, shouldn't really, I guess you shouldn't have to write yourself as a coder. I've already written for you. And you can actually find the source code of all of these functions in my my project folder under MSNC lib. You will be able to find all of the .msnc files that I've already written for you, and allows you to get a lot of different helpful functions for a lot of different things and use them in your own programs. And I didn't mention it earlier, but if you do take a peek at the methodology, for example, let's say slength, you can see everything about the function, including the comments or the underscore def that was passed in with the function declaration. And you can also see all of the I guess parameters and return values that you can get out of that function. So we can use a string for an example here. So if we have a string equals hello, my name is Mason. We go ahead and run that. You can see that we get a string down here, and we want to know what the length of this string is. So I have already written out the complicated logic for you in this method right here. And you can come over here, and if you remember the syntax of the functions, you could say slength width. It does highlight as red, meaning it is currently a valid function with whatever parameters. So it just takes a string. So a string, and that is all, and it gives back iReturn, of course. So you could say println length is iReturn, and of course it says length is 22, which is, I believe, to be the correct length of this string. So I am probably going to go get some dinner, and I'm going to talk to you guys tomorrow about nested functions and polymorphic objects. Alright, I am back, and today I'd like to talk to you guys a little bit about nested functions, and a little later we'll talk about polymorphic objects, but for right now I'd like to demonstrate how one might go about writing a for loop in my language. To demonstrate how to write a for loop in my language, I'm going to go ahead and write a sum of a list method. And to do this, I am going to first need to import list so that I can get my methodology over here, get a few more extra helpful list methods. As you can see, sum is already here, but I am not going to be using that. Rather, I'm going to be recreating it. And so I am importing this so that I can use the get method right here. So it gets an element at a list in an index, and I am doing this so that I can avoid the complicated syntax that I've written earlier, and I have just generalized it and make it a little more simple for me. If you come up here and you see under the sum method, it does return two things. It does have the iReturn register and dReturn register, and this is because the list passed in could either be an integer list or it could be a double list, and I have created this method for both. So in my case, I will not be doing this for both. I will be doing it just for the double list, so that is how I'm going to do that. So I'm going to go ahead and start writing it, and if you can't follow along, that's okay. I'll try to do my best to narrate every single line that I'm writing. So let's get into it. First, of course, we do need our comments, so I'm going to say compute sum of a list. It's going to highlight because it does already exist, but we'll ignore that for now. And we will create a comment string and the param string for this. So we will say sum list. We will do the definition first, and then it's going to be computes sum of a list. And then we will have some list params. That is going to be, let's see, well, over here we got at L param 1, and we have return as it says up here. We will just do that. And we're going to go ahead and run it just to make sure that everything is okay, no errors or anything. So another thing with the syntax in my language, if something does have 2 underscores, it will be minimized, and this will be used as more of a placeholder variable that exists inside of a function, and it doesn't really have too much importance when it comes to computation. Next, we are going to go ahead and write the function declaration. That is going to be some list, and we can copy these and place the definitions and params in there. And of course, we do need closure, so some list. That is all fine and dandy. So to start a for loop, we do need a few things. So the first one is going to be the length of the list, of course, because we do need to know how long we need to go until the loop stops. So this is going to be the length. So we can look over here and see length gets the length of a list. If you remember the syntax, it is length width and then L param 1. So we can just pass in L param 1 again because that is the list that is going to be passed in. I'd like to go ahead and set up a test case for this method just in advance to make sure that the length method works. So that is going to be printing iReturn. And then down here, we can go ahead and start making a little test, some list width. And then we don't have a test list yet, so we can go ahead and make one. I don't really want to make one right now, so I can come up here and I can see the range of method, which is going to create a list with a range of values. It has a minimum, maximum, and gives back a list. So we can go ahead and say range of width, and then it is going to be 2 integers. So it's going to be 0 to 10. And that is all good. So now LReturn will be the list that range of returns, so we can say LReturn here, and we can go ahead and run it, and you can see that the length that is printed is indeed 10. Now that we know that everything works, we're going to go ahead and keep writing the function. So if you've ever written a sum method before, you know that there does have to exist a placeholder value where the sum will be accumulated, and that is going to be a double in our case because we are returning dreturn. So because it is dreturn, we can go ahead and actually just use dreturn right here. And because when we run it, it is already nice and yellow for us, noting that it is a variable already, we can just go ahead and say dreturn equals 0, because when we do import list, the list does import all of these convention names for us already, which is pretty nice. Now we're only missing one thing, and that is going to be the index, or the current index where the loop is. And that is going to be, of course, an integer. I like to call it underscore underscore I because that will go ahead and minimize it for me, noting to me that it is I guess it is an important variable, but for the function it will have to be destroyed later, and I will show you the syntax later. But I, of course, is going to start off at 0, and then we can go ahead and actually start the for loop. So nested functions in my language are probably what you might think they look like. You can actually just append anything to the end of a function's content, and that will count as a code line. So again, I can come into this list and I can define another function being, let's call it underscore underscore loop. And it doesn't have to have any params or definition or anything, it's just a loop, it's okay. So we can go ahead and start the next line. This function does need closure, so we can copy this down here a few times and give us a little bit of wiggle room, and we can go ahead and close it, so end loop. Oh. Alright, and now that we know this function is going to execute however many times we need it to. And we have to execute this function after the function is written. So that is going to be calling underscore underscore loop a certain amount of times. If you remember the syntax, it does have to be compact, and that is going to be from the beginning of the list to the end of the list. So the beginning of the list is always going to be 0, as lists in this language are 0 based, and it is going to go to the length of the list. So if you remember earlier, we got that from up here. and that is going to be iReturn. Now we can go ahead and start writing the content of our loop. So we're not actually in the context of the loop right now. As you know, the loop's context starts with the name and then equals. So we can copy this down here and say equals, and that is going to be the content of this inner nested function. And so loops at the end are going to increment their index. So I is going to be plus equals 1 at the end. So now we can go ahead and start grabbing the value of a list, and we can start adding it to our sum that we have up here. First, we're going to go ahead and grab the first value of the list, or actually just the value at I. So again, we imported this so that I could use the get method, and that is going to be get with, and that is going to ask for lparam and iparam. So we are going to get with the list that we would like, and then the index. So the current index, which is going to be underscore underscore I. So now that we have that, this has actually, or the result of this function will be placed in oReturn, which is now, I guess, a good time to introduce oReturn. So my language does have its own kind of implementation of generics, and that is used with oparam and oReturn. And objects like this can actually be defined with an O object, and it can actually hold anything. And this is just going to be whatever it needs to be. At the beginning, it is going to be a string because that is what is initialized as, excuse me. And this can be now whatever it needs to be. It can be an integer, string, object, double, it doesn't matter. So for this, it is going to be a double, of course, because the user has, or the user may not know exactly what's in the list, and the function does not know what's in the list. So now that we've gotten that, we can actually go ahead and append oReturn to dReturn. So we can say dReturn plus equals oReturn. Now we have officially finished our function, and it correctly should return a double, and that should be the sum of the list. So to make this a little bit easier, I'm actually not going to use 0 to 10, I will use 0 to 5. So we can do that and get rid of that. Now we can say println sum of lreturn is dReturn. Return. Alright. And then you do get the correct answer, which is 10, and that's going to be 0 plus 1 plus 3, 6, 10. As I said earlier, it is important to get rid of variables in a function that we will no longer need after the function has been ran. So down here in the function, we can go ahead and write sum list equals, and to remove a variable from the global list of variables, you're going to use the keyword destroy, and then just the variable name, if I can type, and that is going to go ahead and remove it, so maybe it can be used again in the future by some other function that also uses underscore underscore I or something like that. This was kind of just a simple demonstration on nested functions, and now I'm probably going to tell you guys a little bit more about how you can have conditional function runs. If you are a programmer, you should know that functions don't always run in sequence, but sometimes they do have conditionals that need to be applied to these functions, where one function may run if some condition, whereas another function would run in a different condition. So I'm going to show you now how conditionals and booleans kind of work together to allow for conditional control flow with functions. I'm going to start off by importing the function library, which in itself does import the bool library. And again, the source code for all of these libraries can be found in my GitHub MSNC lib folder. And this can be run now, and we can get all of our methodology over here. And of course, it does have all of these very trivial Boolean operations here that are very useful that I've already written for you, and these functional control flow functions down here. Now, I think that a good way to show you guys how functions and conditionals can work together in a program is by writing the famous FizzBuzz problem. And I'm going to go ahead and write a quick template for that problem right now, and I'll explain it in a second. Here I've written in a little template for the FizzBuzz problem, and you may have noticed up here that I did import the math class, because if you are familiar with the FizzBuzz problem, it does require modular arithmetic and a lot of different control flow operations, so I made sure to import my math class. And if you look over here in the methodology panel, I do have a special method over here called mod, which performs modular arithmetic on two different parameters and stores it back in the iReturn register. I've also created a few helper methods for this problem, being printFizz, printBuzz, and printFizzBuzz. They all take the same parameter up here, being just iparam1, because they will print iparam1 and then their respected keyword. And again, if you aren't familiar with the FizzBuzz problem, I have the definition right here, and that's going to be printing integers 1 to n, but printing fizz if an integer is divisible by 3, buzz if divisible by 5, and fizzbuzz if both. To get started, we do need to log a few variables, so we can go ahead and enter this method's content by saying fizzbuzz equals. And because we're using a loop, we are going to need an I, so we can say I underscore underscore I equals, and if we look back at the definition, it starts at 1, so we will start at 1 as well. We'll create another line where we can create the end index, because if we are using iparam in this problem right here, params up here specifying that iparam1, we do know that we have to log the end index because iparam1 is likely going to change throughout the program, so we can say I end index equals iparam1, and also we know that we are using a loop, so we can go ahead and initialize the loop. We can say underscore underscore loop. I've gone ahead and initialized a few loop exclusive variables, being mod3, mod5, both and not both, signaling whether the current integer is evenly modded by 3, 5, evenly modded by both, or neither. This logical comment right here is the logic that actually is supposed to be placed inside the loop, and this is the official answer for the FizzBuzz problem, so I'm going to be going off of this answer to write my own code. I've gone ahead now and written a few lines here to give us some wiggle room for the context of the loop. And I've also added the closure down here. We can also add in the actual amount of times that the loop is going to be run, which is going to be 0 to end index. We also know that the loop does need to have its variable incremented at the end, being I, so we're going to say I plus equals 1. And now we can go ahead and start writing the logic. So for this first line in the loop, we can see up here that we do need to check for mod3 being 0 and mod5 being 0. So we can go ahead and run that. If you remember earlier, I did talk about the mod function that I did have over here imported in my math library. We can go ahead and say mod with I and 3. And iReturn is going to be returned from this over here. That's going to give us the result of I mod 3. So we can come down here and we can actually check this by using the equals method, and that's going to check if just two objects are equal to each other. And we can check iReturn, and actually we do need the with keyword. So we're going to check the output of this, and we are going to say I0, which is the integer value of 0 imported from my math class, just in case you don't want to write out anything else. With this, we now have the capability to store the mod3 boolean. So we can say mod3 equals iReturn, or whatever the return value of this method is. And if you're unsure about this method, I can come up here and I can show it to you real quick. I realize I didn't actually show it earlier. So the equals method, it takes an object, or actually two objects, and it returns whether they're equal in the iReturn register. And now that we have this little method going on here, we do need to repeat it for 5 right here. So we can go ahead and say mod with I and 5. And I'm going to copy this, give us a little bit more space. We could say equals with I return I0 again, and then we can store mod 5. So we've obtained the Boolean result for both of these little expressions here, and now we do need to AND them together. So that was why I imported my function method, because in itself it imports bool. And up here we can come and look at the AND2 function. It does take two booleans and ANDs them together into the iReturn register. So we can determine if both of these are true at the same time by saying AND2 with mod 3 and mod 5, checking if they are both the same, and now we can set both equal to the result. I'm going to be writing the rest of this algorithm a little de-optimized, including these two lines right here, just to show you guys the speed difference that you can get even when it comes to shorting the program, even a couple lines. Now, we do know that if both, then we are supposed to print FizzBuzz. So we have this little method up here that can print FizzBuzz for us with the I param. So we can say if both, then we can print FizzBuzz with the correct value. Now we do have the capability to store the not both boolean, and that of course is going to be not both. So in the bool class I do have a not method. It's going to be right here. It takes one boolean and returns another boolean. And we can say not with both, and we know now that not both will be equal to the result of the previous method. So now we can actually move on to the next one. So basically we're saying if this wasn't true, but this is true. So we can say and2 with not both, but mod 3. So if this is not true, but this is true, then we can go ahead and do this. So now that we have the answer to that, we can go ahead and say I return, and we can print fizz here. From here, we only have two more cases to cover, and that's going to be this one and this one. And this case, basically in English, is going to be if not both, but mod 5. So with that, we can say and2 with not both, but mod 5, not 4. And we can say if I return, then we can print buzz. Our final case is going to be handling this else statement, and that's basically if none of these are true. So that could be simplified down in English by saying it is neither mod 3 nor mod 5. So we can go ahead and do this by saying or 2, which just ors two booleans with mod 3 and mod 5. And again, it's nor, so neither. We can say not with the result of the previous output. And we can say if I return is true, if nor mod 3 and mod 5, we can just go ahead and print the integer. And with this, we have finished our FizzBuzz method. And I've created a little test case down here doing numbers from 1 to 20. So I can go ahead and run this. And this is going to be the correct output. 1, 2, 3 is divisible by 3, 5 is divisible by 5, 6 divisible by 3, and FizzBuzz divisible by both 3 and 5 is going to be 15. You can check this with the official FizzBuzz answer if you'd like, but I'm going to leave it at that. And down here it does say 55 milliseconds. So that is a long time, especially for any normal program, but again, this is a program built on top of another program. So I'm not really sure exactly what I did expect as far as time, but 50 milliseconds is, I guess, low enough for me. So I'm going to go ahead and show you now how I can go ahead and optimize this algorithm really quickly and get a little speed boost. As you may be able to see up here, I am using both for 3 lines in a row actually, where I am just setting both equal to iReturn, and iReturn is not changing between any of these lines except for this line. So we can actually just come up here and we can substitute both for iReturn. So we no longer need this line, and we can replace both with iReturn. And because iReturn is still not changing, again, we can use it right here. Because we're completely finished with both, we aren't using it anymore. We no longer have to actually define it. And we can go ahead and run that. And we can see we did get a couple milliseconds off our time. Since we're all finished with our algorithm, we can go ahead and start the cleanup. And we only have 3 variables that we need to get rid of. Actually, we might have 4. Yeah, we do have 4. Let's include end index for that because we don't really need that anymore. These are all function exclusive variables. So those are going to be mod 3, mod 5, not both. So we can use the keyword destroy. The last one is going to be not both. And I believe I got all of them. Yep, got all of them. Let's add another colon there. And we can see the time that it adds onto it by running it. And it does add a little bit of time, but it's still cut down from the previous 55 milliseconds. We're still saying sub 50 milliseconds, which is good with me. I think now is going to be a good time to introduce you guys to the final concept in my language, and that's going to be polymorphic objects. So I'm going to go ahead and start by importing object. This is going to have a lot of useful functions for working with these objects. And I'm going to start by creating a template object. To actually create an object, you do need to create a template object for that object. So I'm going to go ahead and write create template object. And the way you create a template object is by saying object and then the name of it. And for this, I'm going to be making a person template so that we can make people. Now I can start getting into the syntax of actually adding attributes and methods to an object. So the syntax to actually add a piece of data to an object that can then be carried down is by using a hashtag. So we can start by making the first attribute of a person, which can be a person's name. So you'll say person hashtag and then the attribute. And you do have to instantiate this the way you would instantiate a normal variable. So you could say name equals template name, because we haven't actually created a person yet. This is still just a template. And a person also has an age, so we can say person age, and then we could say -1. So there are actually two ways of linking a method to an object. So we could say two ways of linking a method. And that is by straight up writing the person hashtag print like this and just writing person hashtag before the function name if you'd like. You can go ahead and do that if you want to. I prefer not to do that. So I go ahead and write parent. So this is going to be the parent method for a person. Of course, it does need closure. We could say print, oh, if I can spell, equals println. We will just say a new line. And we can say println the name of this person, and the name is going to be person name. And then we can also print their age. So println age, person age, and then we will end by saying another print line, just giving us a little bit of space for readability. And at the end, you can go ahead and say person has print. So that's just telling the runtime execution handler that the person template object can use this function. Upon running this, you can see that everything is highlighted nice, and polymorphic objects are going to be highlighted in light blue throughout the program. And over here in the variables panel, you can see that there is a big line here that separates normal variables from objects. Whoops. And it does say the name of the person, or the name of the object, and it does also say their attributes and even functions that are linked to them. And you can see that it automatically threw in person print right here. Now we're at the point in the code where we need to actually create an instance of a person. And we can do that by saying person called, and whatever the name of the new object will be called. And I'll just go ahead and call it Mason for now. I'll say create me. If I go ahead and run this, we can see that it did add another object over here called Mason, and it substituted the person hashtag for Mason hashtag for everything, including the function and the function lines inside. So my language doesn't actually have a constructor when it comes to objects. You do have to do that yourself. So you will come over here and you can look at the attributes that do need to be initialized, and you can see it is going to be Mason name. And these are already created for you, so you do not have to put the S at the beginning. This is going to be Mason name equals whatever it may be. In this case, it's going to be Mason. And of course, the age is going to be 21. So now upon running this, you could see it changed only for Mason. My name is now Mason and my age is 21. And I do have this method down here, so I can actually copy it and paste it right here. It doesn't take anything, so I don't need to say with. And I could just write it right there and run, and it's going to go ahead and print it all nice and neat for me. I'd like to take this code a little bit further, and I'd like to add an attribute to myself that is not a part of this template object person. So you can do that pretty easily by creating any variable that starts with the name and then a hashtag. So I'm going to create a list, and this is going to be called Mason Children. And I'm doing this because not all people will have children, so I'm going to go ahead and just create the option to have even an empty list for children only for me. So upon running this, you can actually see over here, everything is the same for person, but we do have a new variable or new attribute linked to myself called Mason Children, and that is going to be empty to begin with. Now I can start to explain to you guys how inheritance actually works in my language. And the called keyword is actually pretty powerful when it comes to really creating any instance of any object. Because I created a person called Mason, I can now create a Mason called something else. So I can come down here and say Mason called, let's say, Mason's child. So when I run this, it does now create a child called Mason's child, and it also down here it does inherit the children list right here, which is pretty nice because only I was able to have children in the first place, only my children can have children now. I don't plan on having just one child, so Mason's child is actually going to serve as another template object. So I can go ahead and say child, oh, that's going to be an underscore, name equals child name here, just to serve as a template for any children that might be created. And I guess no child is really born with an age, so we can say Mason's child age is going to be 0 to start out with. So if we just print out the template object, so we can say Mason's child, again the print method was inherited, Mason's child print, takes no parameters, we go ahead and run it, so the template object is going to look as follows. I think now it's time to show you guys the real power of how these polymorphic objects can work together to create an efficient program. So I'm going to create a function that's going to be added to myself and myself only, and that's going to be called addChild. So I can go ahead and write the definition now, addChild, and addChild, and I do know that I will be the only one that has it. I can go ahead and write some parameters for it. So addChild params equals, and we'll have this method actually only take a name, so that whenever this is created, we can specify a name, and then this is going to be copied right here, so that this function does know that it takes a string. And I can go ahead and run this, and Mason is now going to have the method addChild, and that is all good. So we can start this off by setting a new name, variable equal to sparam1, because that is probably going to change throughout the rest of the program. And now we can do this by using the create an object. So what this does is it works with the backend. It uses a method called nextVar, which will highlight, and I'm not going to go deep into that, but it's basically going to get you a new object, not necessarily a copy of the object. It doesn't inherit the same way that called does, but it creates a serialized name for a specific object that is stored in the background. So I'm going to say create an obj with, and this is going to take a string and an integer, and it's going to return a list. So it's going to create a certain amount of an object that's going to be serialized. So I can't necessarily create a bunch of Mason's child because they will all have the same name and the program's going to be confused. Why are you referencing the same guy in so many different places that you can't do that? So you do have to create a serialized version of it. So we can say Mason's child. It does take the name of an object and then an integer saying how many of that child you'd like. For now, I'd like to just create one child. And I can show you guys exactly what I mean by this by saying Mason hashtag add child with and then the name of the child. So I can call him whatever I want. I'll say Raymond. I go ahead and run it. And that is actually over here going to create a serialized version of the Mason's child object. And it will just tack on a few numbers to the end. It will be serialized and completely different from any Mason's child object that I might make. And of course I didn't construct this child correctly yet, so I'm still going to have the template version of what it was created from right here. So now that we have this serialized object that is a Mason's child, you're probably asking yourself, how do we actually set the attributes of this serialized name that we don't know? As you know, up here we did just write Mason's child hashtag name, but now we don't really know what the name might be. It might be anything, it could have any random amount of numbers tacked onto the end of it. So that is exactly why I imported my object class, and that is why it has the adders, setAdder, and getAdder functions. So now I am going to go ahead and access the child that I just added. So I did come up here and I imported list specifically to get the head function, which actually will just get the head of a list, which is returned by the create an object. So I will say head with lReturn, and now head is going to return return. So that is going to be the name of the serialized object. So now we can actually use setAttr. And setAttr is going to take three things, being the name of the object, or the serialized name, the name of the attribute itself, and then whatever to set it to, and it gives back nothing. So we can go ahead and set return, which is returned by the head method, or function, and we're going to set its name to what we specified earlier. So that's going to be a new name. And we can also just set the age, even though it likely will be 0, we can also just set it just in case. So we will set age to 0. And now we can do what this method was actually written for, which is adding a child to Mason's children. So I can say Mason children add return, which is going to be the name of the serialized object that I just changed the attributes of. And because we are good coders, we will destroy the function, or just in this case it's going to be a method exclusive variable. I can go ahead and run that and just make sure everything's okay, get a little syntax highlighting going for us. And you can see that I did add a child with Raymond, and his name down here is now Raymond, his age is 0, and I did add it correctly to Mason's children, so it is now sitting in my children list. And now I'm going to add a few more children here just for the next method that I have planned. So I'm going to call one Jacob, then I can create a string for my littlest kid's name, and then it's going to be Mason Jr. I don't actually have kids, just letting you all know. So it's going to be add child with Mason Jr. just for names that do have spaces in them. I can go ahead and run that, and everything is all working fine. It looks like, yep, it looks like I do now have all of these serialized objects added to me. And yep, we do have one named Jacob, we have one named Raymond, and one named Mason Jr. Now, say that I do have a need to access these children later in my program. I would like to write a print children method. So print children, and we can go ahead and end that down here. I'm going to show you how you can access the attributes of all of these children, including their attributes and methods. And I will go ahead and specify now that Mason has print children, so I can only access that. Go ahead and run it. And up here, or I guess down here, you'll see that this method has now been linked to the Mason object. And to do this, I know that I am going to have to loop through a list, so I can go ahead and create myself some room. And I know that I do have to know the length, so I will say length. I can initialize that to nothing. And I do have list imported, so I can use the length method, children, and that's going to return an integer. And I can say now that length equals I return. And now I can declare the loop that I'm going to be going through. I will say children loop, and then end children loop. And then this is going to be run a certain amount of times. So I'm going to do that, and it is going to be 0 to length. Now we can actually start writing in the context of this inner loop. So we can go ahead and copy this, say that. Now we can copy the whole line, and we could do that. So now we can actually go ahead and increment our counter that we don't have yet. So let's go ahead and create that. That's going to be I, and it's going to start at 0, 0 base lists. And at the end of the loop, you do have to increment that, so we will say underscore underscore I plus equals 1. And I think we are all good to start writing the logic. So as I imported in my list library, I do have the get method, which gets an item in a list. So we can get with my children, and we can get that at I. So that is going to return a return right here. And that is going to be the name of a serialized object. So to actually run one of a serialized object's methods, and in this case we will run the inherited child print method on each of them, we can just say run, and it's going to take two things. It will take the serialized name, and it will take the method name. So we can run a return, because that is what is returned by this, and we can run returns print method. And also, because we are good coders, we will destroy any variables we no longer need. And there are two of those, so we can say destroy the counter and destroy the length. And I think that we are all good to run this. So it should print out all of these children's names and ages. I'll go ahead and run that, and it looks like it does run correctly. So now we have all of these different abilities when it comes to all of this data that we made. So honestly, who really cares when all of these things are being done, children are being added, things are being printed? No data is actually being manipulated in this case. No program is actually running. There's no purpose for anything here just yet. So I'm going to go ahead and make a special method that is going to be called advance time. And advance time is going to take a parameter, advance time params, and that is going to take an integer being years. So I can copy this down here, and I can add closure. So this method is going to advance time for, I guess, just me and my children. Add advance time, and I will say that Mason has advance time. I can even create a little test case down here. I can say Mason advance time with, and it looks like it does have that parameter all set up, so I can advance time with, say, 5 years. I can even add down here Mason print. I can print myself. I can also print my children to see the aftermath of the method after time has been advanced. That's actually going to be print children. All right. And the first step in this method is going to be increasing my own age. So we're going to say Mason age plus equals 1. So one of the basics of starting a method in this language is, again, just logging the parameters, because the parameters are likely going to change throughout the program. So we can say advance time equals, we can say, I guess, years to add equals I param 1. And because we are cycling through my children, we do need to advance time for every single children individually. We do need a loop. So we can say I equals 0, and we can create a loop. We could say advance loop. We can add closure, add loop, and it is going to run a certain amount of times. So we will get that ready. It is going to be 0 to, I will make a length in a second. So we can just go ahead and write length with Mason children. Say L, or that's not going to be L, I length equals, or actually we will say underscore underscore length equals I return. So now that should be okay. I'm going to go ahead and run it. Yep, we're going to get some errors, but that is okay. And I think I'm all good to go ahead and write the content. And at the end of every loop, we do need to increment the counter, plus equals 1. All right. And to start this, of course, we do need to grab the child that we're working with. So we can create a placeholder for the name of the current child. So we can get current child equals an empty string. And we can say get with Mason children at I. And now we can go ahead and set current child equal to the output, because we can no longer use overturn. And you'll see why in a second. We will have to use other methods that do work with overturn. And I did just notice that we do not want to increment my own age by 1, but we do want to increment it the same amount that my children are going to be incremented, which is going to be I param 1. Now we can do what this method was actually built to do, and that is increasing the age of each child that I have. And we're going to do that by getting the attribute, and then we're going to increment its age, and then we will reset the attribute. So we will come up here and we will get the attribute. So we will get the attribute of the current child, and that's going to be 2 underscores, and we're going to get their age. And then we can go ahead and create a variable that is going to be the new age. So we could say new age equals O return. It's going to be whatever getAttr returns. And then we can increment this new age by saying new age equals, or actually plus equals, years to add. And then we can reset the attribute by saying set attribute with current child, and we're setting its age to new age. So with this, I think that the method is finished. And down here we say that Mason does have advanced time, so we will call it in this manner with 5 years. Then after, we're going to go ahead and print all the children. So as it's only 0 right now, we can go ahead and run it. And it looks like I will have 26, and all of my children will have 5. And if I change this, it will do what I say, and it will only increment it by 3, even 10, and 10,000. So it looks like everything is working perfectly fine. I forgot to do it earlier, but we will destroy the variables that we need to. So we can say destroy. And we are going to destroy years to add. We're also going to destroy the counter. And we will destroy length. And we will destroy new age. And last, current child. Alright, and then in running that again, everything is fine. And it looks like we are getting only about 15 milliseconds. And I really don't think that is too bad for, I guess, as lightweight as this language can look. Probably doesn't look too lightweight, but at least you don't have to deal with pointers or anything, so there's that. But I'm definitely happy on how this language actually turned out. And honestly, it was just a concept in the beginning, but now it is turned into something that is actually feasible and might be able to really do something, maybe, I guess not really in a production environment, but I'm sure that people can actually create some really cool stuff out of this. This language is still just embedded in Java and is available nowhere outside of just my GitHub. So if you'd like to go check it out, please go check it out. And if you'd like to code something in it and you're having some issues, feel free to leave a comment or even DM me on any of my socials. I will be happy to help out because there 100% still exist bugs in this program, and the only person that's really used this programming language is me. So I can't really cover everything. I actually did have a validator here. If I clear the console and press validate, this will run a little over 2,000 lines of pure MSN code, just validating that all of the syntax still works on everything I currently have implemented. So in case I go into the back end and change something, I can just validate it right here and make sure that everything is fine. But again, this is running about 2,000 lines in 91 milliseconds. So in my code, I think that is okay. But honestly, I am just looking forward to any projects or anything that someone else might be able to make in this. Because I was not always the most creative when it comes to normal languages, but I guess when it came to creating other languages, I could do it for some reason. But I am definitely happy with how this turned out. And I guess I will keep at it. I might just keep adding stuff to it and maybe see if I can maybe implement some, maybe even just cleaner syntax at some points, because the syntax can get a little ugly, a little difficult to read, such as like look at this line, it's carrying over to the next line. But yeah, I'm definitely looking forward to what other people can make. And again, you can find it on my GitHub. I'll link it in the description. If you're interested in seeing the source code in anything, I will actually just go ahead and show it now. So here's my validator. This just makes sure that the syntax is okay with the whole language. And it's just MSN code. You may be able to see some other different commands I didn't actually display before. But again, you have like assert, not assert. Just making sure that things are working correctly. And yeah, there's factorial. Just trying to look for anything else I might have that was a little clever in the validator. Oh yeah, you're also able to actually compare lists by just checking their equality like this, which is pretty cool. It just makes sure that all of the lists have the exact same elements in the same order. Let's see, what else we got? Got some function calls, got some more function calls. The quadruple nested for loop. The syntax is actually kind of funny. Just the triangle of death over here. Yeah, it looks like I showed you guys most of the syntax, and here is some of the source code of my libraries. This is importing ArrayList. It's about the same as list. just a little different. Of course, I do have a set, just doesn't, or it's actually not a real set, doesn't use any buckets or hashing or anything, it just removes duplicates. Um, Function, we do have a couple things here, like running two functions in a row, if else for a function, if a boolean, if this boolean is true, run this, otherwise run that. I do have a map, actually, which doesn't keep unique keys as of right now, it's just a standard map. Here's object again. Everything here, all of these .msnc files will be written in MSN Code. And string was probably the most resource heavy one. Just a lot of string methods for removing characters, getting the index of a character, stuff like that. And my math class, factorial, Pythagorean theorem, absolute value, and bounds. Again, everything here is written in my own code. So I think this is where I'm going to go ahead and end the video, but if you guys have any recommendations, any suggestions for the language, I would be happy to listen to them and maybe even incorporate them into my own language. But if you guys do end up making anything in this, please send them my way. I would love to see anything you guys might be able to cook up. And I guess I'll see you next time. Thank you for staying this long if you did. That's some real effort, honestly. I know I did a lot of talking, but, you know, it had to be done. But, yeah, thank you for watching.